All right. Yo, 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 what's going on, everybody? How's it going? How's it going? How's it going? Another day, another tired Mike. What do you know? I gotta stop. I can't keep using that excuse, man. You guys are just gonna think I'm just, a loser. I'm using the same old excuse over and over again. Oh, he's tired again, tired again. What do you know? Welcome in, everybody. I hope you're having a wonderful day so far. How's it going? No, Mahan, I didn't get to see that yet. Sorry. I just got in. I was just talking on the phone before the stream. I was going to start at 7, but I got up talking on the phone to a family member. How's it going, everybody? Welcome into the stream tonight. Sinopati, what's going on? How's it going? My AirPods got a charge here. That 24%. I got to get some charge on my AirPods before we get some music going. How's it going, everybody? Welcome in. I'm really excited to hang out with you guys again today. Let me know what you guys are studying this evening, what you're working on here in the chat. Let me know how you're doing today and what you're working on and studying. It's great to see you once again. If you guys are still in school, let me know if you're in school, what major you're in. Let me know if it's summer break for you guys almost. Some people, my my brother is on summer break already, so it's kind of crazy. Yeah, so it's kind of crazy that some people are on summer break already, and it's nuts. What are you guys up to? All right, I think we were on a certain. I think we were on a certain problem here. Last time we left off. Last time we left off. Where'd it go? What happened? Did it update to like a new format here? What's going on here? Why is it like this? I'm a man of habit. What's going on? Where is problems? Yeah, they changed this. What is this? Where are my filters? I gotta do this now? Wow, that sucks. Alright, here we go. These ones are SQL, so we're gonna wait on those ones. I don't really want to do those ones right now. So let's do the reverse bits ones again. I think we were stuck on this one last time. All right, let's get this one going. We're doing 190, guys. 190. 190. Reverse bits. Welcome. 190 reverse bits. Reverse bits of a given 32-bit unsigned integer, right? So 32-bit meaning 32-bit, 32 ones or zeros. Unsigned, so it's positive, right? That's what unsigned means. Note that some languages such as Java, there's no unsigned integer type, blah, 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 in Java. Okay, so that's all we got to do. Example, we're given some value of n, which is some string. So I'm going to first just see what we're dealing with here. Let's print out n. I want to see what n is exactly. Is it this or the number behind it? No, n is this. No, sorry. Expected output is this. So n, they gave me the actual integer of n. Okay. So if n is an integer and I wanted to convert it to a binary, if I go print bin n, what do I get? Right? Now I get this binary string here. But the difference is this string, right? This one has 4 characters out front, or 5, 6 zeros out front. But otherwise, everything else is the same. 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1. But here on is different. So why does the expected output, so let me go to this test case is here. Oh, the last executed input, n equals to this. But we printed this to the screen. Hey Tim, how's it going? How's it going, Mr. Tim? Welcome back in, my friend. What you been doing, Tim? Tim. Okay, so this, so in this case, it gave me this n. The integer. Integer. So why does, so I'm curious is to 0, 0. Oh, they say I need to reverse this string. But if I reverse this one, why does the bin cut off? What is this? So what happens if I bin this number? So now I get the 0, 0, 0s on the inverse string of it. So why is this one, what should be the opposite of this one? Right. 1, 1, 1. Well, because this one is also missing the first couple of zeros out front. The 2 zeros. Hmm. Hmm. The input must be a binary string of length 32. this one's 32. No, this one's 32. Hmm. Interesting. Reverse bits. Some languages, okay, so if we're given a large string or a large integer and we want to get every bit off, right? Or it's just weird because we're converting it to binary and it isn't even. Hmm. $190. See, I just don't really know much about binary manipulation. Let's go to the Python docs and let's look up binary. Pickle, data types, built-in functions. Let's look up binary. Convert integer number to binary string with the prefix 0b. The result is a valid Python expression. If x is not Python int object, the method returns an integer. It has some examples. And the prefix 0b is not desired or not. You can use either of the following ways. So you can format it. Huh. Format 14? This. Let's go to the next one. Binary sequences. Let's look up bit. Or the XOR. XOR is not here. No. Dang. Div mod, enumerate, direct class object. Is there like a. Let's look up bit functions in Python. Bitwise operators. Okay, what do these bitwise operators do? These are the Python's bitwise operators. All these operators share something in common. They are bitwise operators. That is, they operate on numbers normally, but instead of treating that number as if it were a single value, treat them as if it were a string of bits written into complement binary. A 2's complement binary is the same as the classical binary representation of a positive integer, but it's slightly different for negative numbers. Negative numbers representing the by performing the 2 complements operation on their absolute value. Okay, returns x with this bit shifted to left place by y places, and new bits on the right hand side are zeros. It's the same as multiplying x by 2 to the power of y. Same as floor division. Does a bitwise AND. Each bit of the output is 1, and the corresponding bit of x and y is 1, otherwise it's 0. So if both of them are 1, it's 1, otherwise it's 0, right? Yeah. Bitwise OR does the other opposite. Returns a complement. There we go, switching each. There's an exclusive OR. Each bit of the output is the same as the corresponding bit in x if that bit is. Each bit in the output is the same as the corresponding bit if that bit in y is 0, and if that complement of the bit in x is that bit in y is 1. What? So these ones might be helpful here. We shift all bits. Okay, so let's go to our VS Code and go to our NeCode practice here. Hey, Don Soap. Okay, we're already on 90. Okay, so we have this and integer. Let's go. So if we bin n and print bin n, what do we get? This here. So let's print length. Let's say m is equal to bin n, and we'll put m here. So we'll say the length of m 28. Okay, so then let's go format. Wanted just the B. What did the docs say? Convert a value to a formatted representation as controlled by format. Or the standard formatting syntax is used. Okay, let's get some tunes going. We're gonna be listening to this guy here. All right, how's that? Okay, so the format, a call to format is translated type value, which is bypass. Huh. Let's look up, like, again, bin. So this said format. The prefix OB is not if is desired or not. You can use either of the following ways. Format (14) which is the B. So then what happens if I give just N here and I print M here? Oh, okay, so you can format an integer, and then if I give a hashtag B, I get the 0B in front. Python, interesting. So you don't even have to do the bin. You can format the integer in binary. Okay. You can also do it with an F string, it looked like, too. So F string with a slice notation. The integer slice, integer with a B cast on it, which is cool too. Let's try that. Right, we wanted this. We wanted N through B. Aha. That's cool. Music's too low? Okay, sorry. What's that? Well, that's 35, negative 35. Okay, so that gives us binary, okay. So we'll say right, if so we need to add, this is a 32-bit integer, this is only 26. So we need to create basically a string of zeros that is the length. So we'll go like this, needed zeros is equal to a list of zeros times the length, 32 less the length of n, right? Or m, sorry. So now if we print needed zeros here, we get an additional 6 needed zeros to turn this 26-bit number into a 32-bit number. So we're going to, basically what we'll do next is we will concatenate, right? 32-bit is equal to, oh, I can't do that. 32-bit is equal, 32 bot is equal to the needed zeros plus or we'll just go, let's go like this, new list. Oh no, I don't want to do a list. Can I do this with a string as well in Python? Yes I can. So we'll go like this, and we'll just go new bit int, right, is this plus m. Okay, so now we print this, and we get our 32-bit integer. Now we just need to print right, the new bit int reversed as such. Boom, that's our answer. There's my answer, at least. Might not be using any bitwise operations, but I don't know. What do you guys think? Okay, so right, we take we're going to return this. This F string, right, with the integer up to, with the binary key here. We say length of m plus m here. That'll return, and then we want to return that. And just stir. Oh, it gave me n as a stir? What is n? What is it doing to the n? What's it doing to the n? What's it doing? Unknown format code B for object type stir. What is it giving me? Object is a stir. What object is a stir here? Let me see if that gives me the same error here. If I stir n here. Yeah, so it's giving me this as a string. Okay, so let's just convert it to an integer then. Why is it? dirt. Bruh. No, n is given to me as an integer. Then what is a string here? Let's try our... Okay. It's giving me n as an integer. Let's do the format then, I guess. Still getting this value error. Hey, what's going on, Mitchie? So why is this working in my Python? This isn't working in... Oh. Right. Hmm. Why is this working my Python? Oh, shoot. See, it's taking n as a string for some reason. Reverse a unsigned integer. Huh. I don't know why. Anybody? Line 6, that's a string. I'm in Python 3. My result is a string. Like, look. I'm getting string by 32 times the length minus the length of the string of m plus m. This works here. Yeah, so the assignment asks for an int. The assignment asks the input must be inner string 1.32. So it gives me an input which is like this. Are they like doing something under the hood to make me not be able to use this? You'd be returning an integer. Oh, it wants an int back. Oh, I need to convert it to the number.
No matter how you travel, it's good to have a plan. Some people plan every minute. No sleep, bus.
Can you convert a number that big to an integer?
Only plan to take it day by day.
I don't know.
When it comes to your finances, a plan is just as
I
important.
didn't see this.
You can count on Credit Karma to give you the
Oh, no.
insights you need to understand your options, so you can take charge of your financial path and find your way to money. Intuit Credit Karma. Karma you can count on.
Ooh.
Download the app today.
What was that ad? Okay, so I don't know what this output is. I gave back this. Huh. Let's go back to those documents for bitwise operations. Let's go here. No results found in the Python docs. Nice. Python bitwise operators are used to perform bitwise calculations on integers. The integers are first converted into binary, and then operations are performed on each bit or corresponding pairs of bits, hence the name bitwise operators. Okay. The result is then returned in decimal format. Interesting. Okay. Bitwise AND. I know about this one. So this one compares the 2 bits of the integers together, or the 2 bits together, bit by bit, and takes. Okay, so bitwise AND operator. This is too loud. I can't even hear. Takes 2 equal length bit patterns as parameters. The 2 bits of the integers are compared. If the bits in the compared positions of the bit patterns are 1, the resulting bit is 1. If not, then they're 0. So if they're both 1, you get a 1. If they differ, you get a 0. If they're 0, you get a 0. In order to result a 1 from the bitwise AND, you have to have both bits be 1. Roger that. The bitwise OR takes 2 equivalent length bits designed as boundaries, so the 2 bits are looked at, positions are 0. The next, if the 2 bits in the looked at position are 0, the next bit is 0. If not, it's 1. Okay, so you have, it's the opposite of the and, is you have to have both of them be 0 to return a 0 value. If it's not, it's a 1 given. Okay. The XOR operator, also known as the exclusive OR, is used to perform the XOR operation on the 2 operands. XOR stands for exclusive OR, and it returns true if and only if exactly one of the operands is true. In context of bitwise operations, it compares corresponding bits of 2 operands. If the bits are different, it returns 1. Otherwise, it returns 0. So if the bits are different, it returns 1. Otherwise, it returns 0. Take the 2 bits of values of x and y, where x is equal to 7, 1, 1, 1, and y is equal to 4, 1, 0, 0. Take bitwise of both y, x, and y. So because the bits of either the 1 and the 1 gives you a 0, if the bits are different, it returns 1. Otherwise, it's 0. So these 2 bits are different, so you get 1. Okay, got you. So like bits get 0, unlike bits get 1. The bitwise NOT. The preceding 3 bitwise operators are binary operators necessitating 2 operands to function. However, unlike the others, this operator operates with only one operand. The bitwise NOT operator works with a single value and returns its 1 complement. This means it toggles all bits in the value, transforming 0 bits to 1 and 1 bits to 0. With a single value, it returns its 1 complement. It toggles all the bits in the value, transforming 0 bits to 1 and 1 bits. Okay, so it just transforms. Okay, got you. Flips it in terms of each bit. Not a mirror though. Okay, bitwise shift. These operators are used to shift the bits of a number left or right, thereby multiplying or dividing the number by 2 respectively. They can be used when you have to multiply or divide a number by 2. Bitwise right shift. Shift the bits of the number to the right and fill zeros on void left. Fills 1 on voids left. Fills 1 in the case of a negative number as a result. Similar effect as of dividing the number with some power of 2. So in the example, we call A is equal to 10 here, which is 0, 0, 0 in binary. 0, 0, 0, 1, 0, 0. Oh, sorry, 1, 0, 1, 0 in binary. If we call A bitwise right shift 1, so it just pushes, it just kind of creates like a what is it, a circular queue where you just load in, you just keep make a circular kind of motion here, a clockwise motion. Items rotate in and out of the clockwise motion. Okay, so then this is helpful for our case here. Oh, this was our project diagram. Should we frame this? Okay. So if we're given so it'll give it zeros and fills zeros on voids left as a result. What does that mean? And rotate counterclockwise in this one. Whereas 5, rotate 1, moves this 1 over 1 position here. Basically multiplying by 2. This is dividing by 2. Okay. So if we shift over, let's ask the Almighty here. Yeah, these ads are brutal. I was about to say, huh? We gotta open up a chat. Gypped. For bitwise right shift, what does the fills 0 on voids left mean from the docs? When the docs say bitwise right shifts fills 0 on voids left, they're talking about what happens to the empty spaces, the voids that are created when bits are shifted to the right. Here's what it means. An 8 in binary is represented as 0B1 0 0 0 0. We shift by 1. 0B1 0 0 0 is 8 in binary. Shifting right by 1 moves all the bits by 1 position. So it becomes 0B 0 1 0 0. Right? This 1 moves here, and this 1 moves here, or this 0 moves here, which is 4 in decimals. So the 1 from the left moves to the position. So the 1 from the left moves right 1 position. The empty leftmost bit, the void, is filled with the 0. Oh, okay, got you. So it just rotates. Oh. Oh, so it's not circular. Bits that fall off are gone? Or do they wrap? They're gone. Bitwise shifting is not circular. When you do a shift like X1 bitwise right to the one place, the bits that fall off the end on the right are discarded and the left side gets filled with zeros for positive integers. Think of it like this. Huh. So think if you had this number here and you also did x by 2. So this would shift these zeros off this 1 over to this place and have 2 zeros here. Huh. So in the case of our problem, we're given an n value that we're converting to a binary string. We are then so if we need to shift these Oh. This is interesting. This is interesting. So if we shift these, in this case we have 5, 0. So this is the value that we're on, and we want to move it to the left. If it's in this example here, our binary input was this. We shifted here. 1, 0. 0 got put here, and the 0 moves here. So in the case that you have a length of 32 already, interesting. Yeah, I was using the bin function earlier, and then I was looking up how to get rid of that b, and then you can use this. And then the Python docs told me to use this format method to get rid of that b without having to it'll just automatically do it for you in one line here. Okay, so if the integer is less than, we need to shift right. No, we need to shift left by that many bits, right? But does that work for all cases? Like, so can we say like, we'll say that we'll override, say this is m, we'll say that m length is equal to the length of m. We'll say if length of m less than 32, the length of m is less than 32, then we're going to, now how can we use the shift here to shift? How does that create the reverse bits effect? Reverse bits would be good. So just reverse the entire string, not the individual bits themselves. So the 0 here stayed 0, and it just went over here.
Work goes smoothly when you know the right steps. With Asana, you can coordinate tasks across teams and stay on track, so your team can spend more time celebrating wins. Try it for free at asana.com.
hit pause
Hmm.
on whatever you're listening to and hit play
Come
on your
on,
next
get me out of
adventure.
here. Gonna give
Stay
me a
too
full
nice and get a
15
$50
second
Best
ad.
Western gift card. Life's a
True.
trip.
Because, like, if you shift bits in this example here, this goes here and the 0 falls off. The 1 falls off. So, do I want to just shift? Can I treat it like a pop? Can I capture what falls off? So what I was doing before was saying, okay, get the binary string, and then I was going right, I was taking new is equal to zeros being times 32 less the length of m, right, plus m here. Right, and then I was just reversing that string, right, in theory. That's what I was doing in my Python here, right? So now I need to get back to the, now what happens if I call, what is it the char function? No, it's the chur. Return a Unicode string. No, it's not that. Of one character, no. If I call into this, it's not working either. New bit int. So we reverse it. Why do we lose bits here? Why do we have different lengths now? Oh, you lose your preceding zeros? Oh. Because you're converting that to an integer. We need to go from binary to an integer. So right now I'm in binary. Now I need to go from binary to an integer. So, does Python have any built-ins to go from binary to an integer? Binary to integer. binary list to integer. Okay. Oh, well, this I think just gave us the answer here. Dang it. Oh, well, we got spoiled here. We were on the grind. Okay, so that was going to be my next approach here, was that if we turn every letter into a list, rather, using Python functions, you shift. This is probably the answer right here. Oh, this gives you the mathematical approach. So you take a binary list is a representation of zeros and ones using int with a string conversion. This is the most efficient method. The map converts each element of the binary list A to a string. Okay, you convert all elements in the binary list to a string. You join them into a string. The join combines the list elements to a single string. And the int function interprets that string as a binary number base 2 and converts it to to an integer. Oh, you can give a parameter to an int function? I didn't know that. So if we go this and we give a parameter to this int function of 2. Oh. Uh-oh. No. Good thing I copied these. Gotta log in. What happened? My Leet code is bugging out. Does not want me to solve this one. Way faster than all these suckers. Let's go. Look at that. Ha! We got it, boys. Woohoo! So the int will recognize with this parameter that's a binary value and convert it to a 2. I didn't know that. That was the one thing I needed. So int string 2. Can you explain the 2 param in the int function? That second is the base of the number system you're converting from. So you can just use that conversion on the int function itself. So we can get rid of this, put that there. We can do this. Like so. Just get rid of that like that. A little bit cleaner there. We could move it up into one line. Ooh. Oh. See now, well, I gotta calculate it twice. That's why I made it into a variable actually. All right, we'll look at this here. Okay, so you can just do an F string on N, convert it to a 32-bit base using the same kind of formatting. Okay, so there's different, there's levels to this thing, I guess. There's, where'd that go? Where'd that go? Right, so you can even specify further a 32-bit integer and then convert, and then yeah, okay, got you. Okay, so then you can just do this, right? Rather than doing this approach here, you can do a 32-bit integer, 032-bit, 032b. Sounds like a bra size. And then you do that handles all of this. So that just makes M here. So then you just put M there. Which in theory, you can just take this, put that there. Now, you're on a single line, and you're passing the LeetCode problem. Okay, so you can even use these format strings to even further specify a 32-bit value rather than doing the auto appending or concatenation of the amount of zeros you need to make a 32-bit if you're short. Yeah, sorry, Norpai. I saw your chats on Twitch. I was just focusing trying to solve this one. I knew you guys knew how to solve it. I was right there. I just wanted to. I just was missing one little element here. Nope, there is. Yeah. Sometimes I'm scared to read chat because I don't want to get hit with the spoiler. So I. Not that you guys spoil, but I just, I'm scared. So I don't want to ruin the experience. Especially if we're getting like close to the end. All right, cool. That was that one. Ooh. Well, there you go. Hopefully, good thing that didn't show my password. Sort by hard. Next one for tomorrow is going to be, these ones are SQL ones. I don't really want to do those ones. So this one is a SQL one, I think, too. 10th line. Is this a SQL one as well? Oh, bash. Whatever that is. Rising temperature. Another SQL one. Happy number. Write an algorithm to determine if a happy number n is happy. A happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. Starting with any positive integer, replace the number by the sum of the squares of its digits. Okay. So our first part of the algorithm is, so we got to say if n greater than 0, right? We need to convert stir n is equal to stir on n, and say for, I mean, we could create a list, but I don't know, maybe we don't need to. Say for val in stir n, we're going to can we just replace the current value and move on? So let's actually loop using indexing on this. So let's go stir I. So let's say for I. So we'll say m is equal to the length of stir n. We say for I in the range of m. Let's go. We're going to be on every stir value of n, which is, so we're going to say stir n index I is going to equal to int I squared, right? And then technically we've already seen every value, so we don't need to call sum on it again. We can not do extra work. We can just sum currently through this loop. So we'll say that the total is equal to, or say that new n is equal to we don't even need to process this, replace the value in the string even to sum it. So we can just call this and just do a sum. I mean, we could even break this down into a list comprehension if we made all the values into a list. Right. There's a couple of ways we could definitely do this. So let's just, I don't want to get off track of our current approach, but so if, right, or starting off, if it's greater than 0, we convert it to a string. We get the length of that string. We're going to generate a new m, which is a sum of all these values. So say new n plus equals to the int of, not of I, but of m index I squared, right? And then repeat the process until the number equals 1. Oh, starting with any positive integer. Oh, wait, I didn't think about this. Oh, you take the value. So new n. Until it equals 1 where it will stay, or it loops endlessly in a cycle, which does not equal 1. Those numbers for which this process ends in 1 are happy. N squared is 4. So it loops endlessly into a cycle back onto the original n. So while n does not equal to n, we'll say while n does not equal to new n, right? So if you reach your number again, or it loops endlessly in a cycle, which does not include 1. So while n does not equal to the new n value, yeah, we did, Tim. We did. We're giving this one a little bit of a go. I might not keep going on it because I kind of want to move on to something else. But so while the n int is not equal to new n, we stir n. So let's just go length of stir n. New n equals to this. If new n so we need n to change here, or new n. So n, it becomes new n. So if you multiply it and sum, your value will always be greater until you become until you're less. So while nu n is greater than n, right? So we'll say if nu n equals to n false here, vector false here, it becomes less than. So you don't even need this right here. Turn true here. So while the new n value is greater than n, so while n, I guess, does not equal to 1, if nu n is equal to n, return false. We're going to generate a new n. If nu n is equal to n after generation, return false. Return true. Int object not scriptable. I missed the length. Oh, hold on. Oh, because we need a... we'll say stir. I need to... calling stir in here. Length of n. So we call stir n here. We need to index into a stir of n on the length of it. So we get an infinite loop here. So while n does not equal 1, we convert the n to a string and we get that length. We then are going to get a sum for a new n. We say for I in the range of the length of the string of n, right? We're going to increase our new n value by the current character right, powered by 2. If new n return false, new n is equal to n we try to stir the n. That converts it to a stir. Okay, let me take this and move it in. This is 202. Okay, so we got an n of like 19 should be true. Okay, let's go ahead and debug this one. Yeah, that's probably right, Sino. Okay, so n is 19. We're gonna step into this. Stir 19. M is 2. 0. One squared is 1. 9 squared is so 82. If nu is not equal to n 19. And 68. But n got overrode as 82 here. Why? N is equal to nu n. Okay, so then what we'll do is, let's stop this. Let's say n is 19. So we need to make a copy of this value. So in Python, you can make copies by doing that, right? So if is equals to copy, return false. Yeah, in object not scriptable. So how do I not make a reference or an alias? How do I instead make a copy of n without actually manipulating n? Let's see here. $19, 82. Copy still 19. Okay, good. Okay. Okay, so it's now I think we got it here. So while n, so we're gonna get copy is equal to n here. And we're gonna say if equal to copy, we're gonna return false. We get string. infinite loop. What am I missing here? If n is equal to copy, return false. N is equal to new n. N stir n equals to stir n. M equals to the length of stir n. New n equals to 0. For I in the range of m, new n plus equals to int stir I index I power 2. If new n is equal to copy, then return false. Return true. Where is this looping? $68. $100. Returns true. It's a happy number. And it's equal to 1. So then on an unhappy number, on 2, okay, we go into our range, we get power of 4 becomes new n does not equal to copy. New n becomes 4. New n becomes 16. So the next one should be 7 because we plus 1 to the 36. $58, $89, $145, $42, $20, $4, $16. Okay, so it doesn't loop on n, it loops on 1 on the next iteration of n, on 16. 20 equals 4. So if it equals to copy here. So now if I run debug this, it becomes 2, then goes to 4, 16, 37, 58, 89, 145, 42, 20, 4, Okay, so it's our condition then, I guess. So we make a copy up front. Right away we want to evaluate, is n, if it's not n, well, is it equal to our copy? Why is my, what's going on here? Oh. So we'll take this, paste it here. So if n is equal to copy, return false right away. Try that. So 19 we're getting false. Oh, because it's just eating it right away. So we don't want, right, because right now we're copying n, and then we're just checking it right away, and then we're returning false. So we're not even doing anything. So what if we do the power operation? What if we do the power operation right away on n? Power by 2. Okay. We have n copy, and we have n is equal to n power by 2. Right, if we take a copy of it and then multiply it by 2 and then go in, or power it by 2 and then go in, we won't hit this right away. Now I'm getting infinite loop. Yeah, it's going, Scary Sticks. What's going on, dude? Welcome back in. Okay, so we have this. Print. Let's print false here. Let's current. Save. 18. And debug. No, I don't want to power it right away. Anything put that there. Let's exit this. Let's run and debug this. 18. One. $19, $82, $68, $100. True. Okay, so then on 2. 4, 16, 37, 58, 145, 42, 20, okay, so then now new n is 4. It's not equal to copy. It's set to 4. And then we loop back to 16. So the loop is taking at the first iteration forward. What do you guys think? Anybody out there? Anybody out there? Okay, so right, it's coming down to the 4, but not coming all the way down to our 2 because the 4 is going and being processed here and being made into a new one. I mean, all these values were unique, so like we can have like a set and say if new n in set in scene print false, we add the new n. Two, 4, Oh, okay. So let's take this then. And let's go over to here. Let's use a set rather. And then let's do returns here. Got false. 19. So does 19 show us as value that's been seen before? But it resolves itself down. Oh, so maybe we can't use a set. 19, 82, 68, 100. So let's say while true, if new n equals to 1, return true. It's returning false. If new n equals to 1, return false. Do this one. 19, 82, 68, 100, 1, print true. We add it. Okay, so you want to add it after you check it's not true. There we go. Okay, so you say yes. Let's go. Got it, boys. Man, that took a little bit for me to debug, but we got it. We got it pretty quick. We got a fast one there, at least. O of n. Okay, so what I do is I say while true, I convert the current value of n to a stir. I get the length of that stir. I am going to get a sum of all the values, iterating through. So do I need even m here? Hold on, let's see. Let's get rid of m. Let's just say for char in stir n. we're gonna int the char by power 2 new n. If its new n is 1, we'll return true. If new n is seen, we'll return false. We'll add it to our scene set, and we'll continue forward. Beautiful. If you guys are still here with me, leave a like for that one, boys. Oh yeah. How does this look for my solution? Using a set to track previously numbers and avoid infinite loops. Exactly the right approach for this problem. Here's a quick breakdown of why it works. Cycle detection. You use a scene set to detect loops. If you're in a cycle, you're a happy number. Conversion and squaring. You're converting the number to a string, iterating through the digits, squaring them, and summing them correctly. Clean logic. You could use a helper function to do the get next. So you can say while n is not equal to 1. Return any true. Oh, so then you say just in this. Return if n equals 1. New n. This wants me to add the scene after we assign. Add it right away after we've seen it. And run. Minecraft tonight? Oh, because we're gonna do we want to add it up front before we do compounds to it, because we want to make sure we get the first one. And Let me save n as new n on each pass. There we go. Perfect. I don't get it why the seen becomes the false condition. What do you mean, Senopati? Okay, so it just comes from what the problem said is that, and what I noticed through my debugging is that when you go through this process, you don't you will never repeat a number like throughout the entire line, right? You only repeat a number. So, for example, if we start off on some value x, it's going to give us some value y. It's going to give us some value z. It's going to give us some value a, and then eventually it'll eventually give us either 1 or it'll wrap back to this value. As you can see though, all of these values with or without 1 are unique, right? So you can put all of them into a set basically, right? And then if you get back to one of them in your set, you know you have detected a loop rather than hitting the 1. Because so what I noticed at my debugging is as we went from x to some value to some value to some value to maybe 1, right? Or back to this value, um, I I noticed that none of these values were the same. Like none of these question marks were the same. They were all unique. So I that's what gave me the set idea. Does that make sense, Senopati? Senopati. All right, you guys. This marks the 2 hour mark of the stream. If you guys are here, thanks so much for being here. And please leave a thumbs up if you guys are joining me for the study session of some Leet code problems. We solved 2 of them today. So pretty good solve. We learned about bitwise operators. I feel a lot more comfortable with bitwise operators. The XOR, bitwise and, bitwise or, like XOR, the bitwise not operator. I feel a little bit better about understanding the shift, both left and right. And so I was really lacking understanding of what those operators actually did, and I was kind of scared of them. But now I really I feel better about them now that we did that. So if they repeat the previous digit, so it will repeat the same process. Yeah, like the problem specifically said that it will infinitely loop upon, like it'll loop on that in a circular fashion. So that little key note was like, okay, then I'm going to come back to some value, but I had to understand, well, in between there, are we seeing any other duplicate values? And the answer was no. Is on every summation of every digit squared for that value or that n, you get a new unique value until you either reach 1 or you come back to the a loop on the n, the that's the first iteration after n. How many problems have we solved so far, everybody? Anybody want to guess? Are we at 50 yet? How do you see solved? How do you see solved? What is this new format? This sucks. How do you see solve count? Here we go. 50 problems. Let's go. Exactly 50. No graveyard shifts tonight, Tim. Probably not. I'm probably gonna end up calling it here. Actually, I wanted to show you guys the project that we've been working on for the past couple of days now. This would be we only done 2 days of work on the project so far. We've got a good running, no running project so far. This is our thin layer chromatography simulator. I have a degree in human biology and a minor in chemistry, for those that don't know, and I work as a formulation chemist. And where the tunes go? Oh well. And so I thought it'd be fun to model like one of our beginning, like, more elementary labs of thin layer chromatography or paper chromatography on using Python and Matplotlib. So what we did was we are using generating compounds via this class I created, a compound class with some various functions to get data, update data. We are generating five compounds, one of them being a solvent compound with a retention factor of 100%. So this will be our lead horse, basically. And then every other compound will have a random factor generated between 0 and 1 to basically lag behind the solvent so that you can, you can see the movement of those through via polarity or whatever. So, right, and then we just set those compounds into this format here so that we can appropriately read them into the, we generate all of the X data here by going through and populating, um, we generate data for every compound given its, key as its names, right? So we generate all the X data for every compound and all the Y data for every compound in an array, in a like an array, right? Um, or in, sorry, a dictionary here for each compound. And then we're gonna go ahead and we plot them all, right? Cool. So this is what I was able to come up with here. So it's kind of going a little bit slow here for right now, but as you can see on the far left, you have the solvent, the black, traveling up the y-axis at 100% speed, whereas the other compounds are randomly generated, and you can see that they slowly traverse and scale up depending upon that random retention factor, which is depicted by, which is normally calculated mathematically by the chemist or whatnot. So you would run this experiment, and then when it finishes, oh, there it finished over at like the right where the black finally meets the top. You would stop at that point in time. You would take it out of the solvent, so the travel would cease, and then you would you know just take the level at which the black is at and the level at which the blue is at and take the ratio of them, and that is the retention factor. So we're pre-baking in the retention factors to come up with the visualization. um, and so, but in the normal lab setting, what you would do is you would take this height here, and you would take this height here, divide it by the black height, and that would give you a retention factor for this compound. And so these two have a pretty similar retention factor that was generated at this run here. So in the last stream yesterday, what we did was we added some randomization algorithm to the overall plotting points to have some buffer between on the x-axis. So instead of it just being a linear line going straight up on the x-axis, it's has a little bit of sway, so that kind of mimics like a fluid kind of slowly, creeping up along different, points along that's that vertical plane or whatnot. Excuse me. Jeez, hiccups galore. Oh boy. Oh my gosh. Okay. So, hey Intelligens, welcome back, dude. Welcome, welcome, welcome. You're awesome. Appreciate you for being here and leaving a comment over on Twitch. I wanted to tell you guys, so tomorrow, the plan for tomorrow, be here tomorrow. We're going to be diving into Fast API. So tomorrow we're going to be starting to write the front end for this project. My goal is to get some basic HTML boilerplate for adding in up to 5 compounds, and then supplying them, retention factors or generating random ones if you so be it. So the user will be able to provide a custom retention factor, or press a button to generate a random one and have it be inputted into the box for it. and then they'll be able to run and have this simulation be displayed to them on the web. So that's my goal for tomorrow. So be back here tomorrow if you would like to see me do that. We're going to link up this back end algorithm, or not really a back end yet because it's not, it's just an algorithm to generate these plots and whatnot. But we're going to kind of structure it and get a front end set up and then link it to a back end using Fast API and HTML and CSS and Python. We are going to then, my goal is I think it would be kind of fun is we could really expand this project to kind of like a website that will be kind of like a a fun science data center, like maybe it's like some games or these various simulations, right? So like for the whole point of this lab when you do it is that you have an unknown compound. Let's say that our purple was our unknown compound here, well, and that this yellow, well, you could make the inference that these two are the same compound in this lab setting. So, um, no, I don't want to learn frameworks. Um, I need to learn raw language before I start cheating with frameworks and stuff and going on. I need to get a basic understanding of what I'm actually doing and stuff like that. And all that, those frameworks and Tailwind and all that stuff will come later. But there's been plenty. They have plenty of opportunities and abilities to write good stuff with what we currently got, the bare minimums. So, anywho, I appreciate you guys being here so much. Also, what was I talking about before? Yeah, so Fast API is tomorrow. Front end stuff, getting this linked up. Well, yeah, so like a fun like little like science fair. I think like sciencefair.com would be a cool like little name or something where users can just come and have a bunch of fun little simulations they can play with or little science games or whatnot, and we can even open up that to the as another open source project for the community on the Discord, link down below, and on my channel on Twitch, on my profile. So yeah, I'll be back here tomorrow for that. And then there was one more thing I wanted to say. What was it? What was it? What was it? Yeah, exactly. Like cool math games, cool chem games. Yeah, exactly. That's exactly what I was like referring to. But that's like a lot of games. That's like flash games and stuff. Um, there was one thing I wanted. There's something I wanted to say. Totally forgot though. Huh. I'm sorry, you guys. That sucks. There was definitely something I wanted to. Oh, so yeah. Also, we have the Small Business Manager open source community project linked on my GitHub, and we also have a section in the Discord where we have a going chat about features that we want to upload and add into it. I believe we got our first two pull requests already, so we're going to evaluate and review those on stream shortly. And if we like them, we'll merge them into dev, and then we'll all work off of dev from there. So if you want to contribute to the community project and really take an opportunity to showcase your work, and then use this opportunity to work with others and then leverage that into a point on your resume. Like I collaborated with X amount of people on a community open source project that was that encompassed an entire small business ledger from accounting to inventory expenses and automated accounting and whatnot, double entry and whatnot. So you can really leverage these things if you're creative with how you use them. It's not a lie. That's exactly what you did. You're just saying what you did. So, take that opportunity to work with us on the Small Business Manager Community Project. We'll go over the pull requests probably on the weekends, like once every weekend, we'll go over the pull requests into a session to either merge those in. So, if you're wanting to work on that, then make sure you're working off the dev branch. If you try to merge and submit a pull request into main, I will reject it or send back a comment for you to change it over to the dev branch. That's where everything will be going for working versions until we get a working package that we like and want to merge into main as a release for like 1.1, point 2, and we'll tag it as such. So I'm really trying to get more familiar with Git and use it appropriately. With this current project, we are using Git and GitHub and really branching on every new feature we're making and merging in appropriately and doing everything the right way. So thank you guys so much for being here. Leave a like if you enjoyed the stream. Sub along if you want to code alongside me every single day around 7 p.m. PST, or if you want to just hang out and learn or just listen and whatnot. Use this opportunity to hold yourself accountable. No, don't procrastinate your studying. Better yourself, better your understanding, better your current intelligence levels, and just become a better more intelligent human being overall. Thank you guys so much for being here, and I'll see you guys later. Chat with me in the Discord. I'll potentially stop in and chat in there in the general chat. Peace out, guys. Bye.